Hello and welcome to Network Theory. Today's topic is on the superposition theorem. The references which have been used: Ravi Singh, Circuit Theory and Networks, Analysis and Synthesis; William Haight, Electrical Circuit Analysis; Alexander and Saduku, Fundamentals of Electric Circuits. So basically we are speaking about the superposition theorem, explanation and some examples with independent and dependent sources. Okay. So when we are speaking about the superposition theorem, it is defined for a linear network containing more than one independent source or dependent sources. So it is for a linear network and there should be at least two sources or more than one independent source. And there could be dependent sources also in the circuit. So now what is the meaning of a linear network is that there should be a linear relation between the voltages and the currents, or you could say that it obeys Ohm's law, right? For such a network you can apply superposition theorem provided there are more than one source. Now, how do you find out and how is it defined as the resultant current in any element? When you're finding out the current through a particular element, what do? You consider each source, independent source, acting alone. Note the point that we are speaking about independent sources only. So consider each independent source alone, find out its contribution to the current flowing through an element, or with one source acting, what is the current in a particular element? This is found out. Now, what do you do with the other sources at that time? So you turn off all the other independent sources. So when you are considering only one source, all the other sources, be it voltage source or current source. So voltage source and current source, whatever it is, they are made zero, or they are turned off, which means what? Voltage sources, you can replace it by short circuit. To make a voltage zero, you replace it by a short circuit. And to make a current zero, you open circuit it. So current sources are replaced by open circuit, voltage sources are replaced by short circuits, and there will be only one source at a time. So you consider each source at a time, finding out the current through a particular element. So different cases are considered, and finally the total sum, algebraic sum of the currents are that would be produced in the element is found out. So it would be like I is equal to I1 plus I2 plus etc etc etc. So this is how it is done. Now note the point that we speak about independent sources acting alone. So what do you do with the dependent sources? Now dependent sources you cannot make zero. So dependent sources are sources which we have already discussed in another video. So dependent sources cannot be made zero. Why? Because they are controlled by some other parameter. Right. So, for example, any dependent source depends upon either a voltage or a current in the circuit. So, since these are not constant, they cannot be made equal to zero. So, the dependent sources are kept as such, but independent sources you can make equal to zero when one source is being considered. So, this is what the superposition theorem says. Okay. So let's consider an example here with the superposition theorem, and you are asked to find out VO. VO is the voltage across a 2 ohm resistance. Now, since we are using superposition theorem, we have to consider there are two sources here, 5 ampere source and a 12 volt source here. So these we consider by superposition theorem, we consider one source at a time, the other sources at that time being turned off. So let's consider the 12 volt source alone first. So let's consider this first, and then what do? So this 5 ampere source has to be made off, or it is open circuited. So once you open circuit it, we have a circuit like this, and this is our whole circuit. So we have removed this. Now this becomes a simple series loop, series circuit, and you can see that there is a resistance of 2 plus 3 5 5 plus 5 10 ohm. Total resistance is 10 and the voltage source is 12 volt. So the current is going to be 1.2 ampere. So let me write it off. The total current through the circuit, now the current through all the elements is the same. So I is 12 divided by 10, or 1.2 ampere. Now the voltage VO, this is the voltage across the 2 ohm resistance. So VO, it is equal to 2 into I, the current into the resistance, which is 2 into 1.2, 2.4 volt. So this is I can call this as VO1. So this is case 1 where you have got only the 12 volt source acting, right? Now let us consider the case with case 2 when you have the 5 ampere. So the next case is where the 5 ampere source will be acting and I will make this equal to 0. The 12 volt source you can make equal to 0 by short circuiting it. So let's consider that case now. Okay. So this is our original problem and now we are going to be considering the 5 ampere source alone. When I'm considering the 5 ampere source alone, what do we do with the 12 volt source? It has to be made 0 or in other words short circuit replaced by a short circuit. So once I replace this by a short circuit, this is our equivalent circuit. Now we can see that this is 5 ohm and it is in parallel to this total resistance. 2 and 3 are in series, so total 5 ohm. 5 is parallel to 5, which means that there is a current source and it will divide into these two parallel paths. Since both the resistances are equal, current will divide equally. So you will have a 2.5 ampere flowing through this, right? So which means that 2.5 ampere is the current which is going to be flowing through both the 2.5 ampere, 2.5 ampere, right? Now, what is the voltage across the 2 ohm resistance, which is VO2? That is what we are supposed to find out. Will be equal to 2 into current, which is 2.5, which is 5 volt. So, which means what? Your VO2 is 5 volt or your overall VO, which is the case of VO1 plus VO2. That is going to be, first case, we got a 2.4 volt. That is with the 12 volt source acting. Now with 5 ampere source acting, we have got a case of, we have got 5 volt. So effective voltage is 7.4 volt. So this is how we have done considering different sources individually. 12 volt source first, then 5 ampere source, then consider the contribution of both and add them to get the answer, right? So this is how we do, and this is the case with independent sources. Now let's see the case with dependent sources. Okay. So here we have a problem where there are three sources, 25 volt, 5 ampere, and there is another source of 0.1 Vx. Now these two are independent sources. You can see from these are constant values, whereas this one is a controlled voltage source. So controlled current source, sorry. It is a 0.1 Vx, means it depends upon Vx. It's a voltage controlled current source. The voltage is Vx. You are asked to find out this Vx using superposition. So what do we do using superposition? Consider each source at a time. Now the only problem is that here we have got a dependent source. A dependent source you cannot make 0. So dependent source is 0.1 Vx. It is cannot be made 0, right? So it is kept as such. But we are going to be considering the 25 volt source individually first, then after that you are going to be considering the 5 ampere source likewise. So remaining part remains the same. With the 25 volt source acting alone, what do we do with the 5 ampere source? Again, it is made an open circuit and we are ending up with this, right? So here we can see that the 5 ampere source here has been made equal to 0, and this is our circuit. So this circuit we can apply. So what are we supposed to find out? We are supposed to find out this voltage Vx. Now this is open circuited. Now here we can apply. So let me draw the circuit and then let's see. 25 volt, 20 ohm, and the current had been open circuited. So this was 4 ohm and I've kept the 0.1 Vx as such. So it is not to be made, it is not to be changed. Now, this is the voltage Vx. Now, here to solve this, the easiest method is node analysis. So, I'm going to be applying node analysis here. So, node analysis we have already seen in other videos. So, please refer to that. Now, Vx minus 25. The current through this branch is Vx minus 25 divided by 20. The current through this branch, that is 4 ohm, is Vx divided by 4. and there is a current which is flowing into this, which is 0.1 Vx. So basically we are node analysis, applying node analysis, and here node analysis, and here it is nothing, node analysis is nothing but KCL. So what we have done is applying KCL at this node. There are three branches, 1, 2 and 3. Current entering is 0.1 Vx, that is equal to sum of the currents leaving the node. At this node, the currents leaving are Vx by 4 and Vx minus 25 divided by 20. So this is what we have obtained. Now once we solve this, so solving, we can find out Vx, and we get Vx is equal to 6. After solving this, you get Vx is equal to 6.25 volt. Right? So this is the first case when we have considered the 25 volt source alone. Now the second case is, so this is our original circuit. The second case, we are going to be considering the 5 ampere source now. At that time, the 25 volt has to be made equal to 0 by short circuiting it. Again, observe that the 0.1 Vx source is kept as such. So here you have got the voltage source has been short circuited here, but the 5 ampere current is there. So again, we can apply node analysis, and when I apply node analysis at this particular node, so here we can see, let me just say, the currents 5 ampere is flowing into the node, 0.1 Vx is also flowing into this node, whereas the currents flowing out will be equal to, so the current, there is a current of Vx divided by 20, which is flowing out like this. This is your ground potential, so obviously the current is going to flow out like this to the ground. Similarly, there is this voltage is Vx, so Vx divided by 4 is going to flow like this. So node analysis, doing node analysis, we are going to be writing the sum of the currents leaving the node is Vx by 4 plus Vx divided by 20, and the currents which are entering 5 ampere and 0.1 Vx. So it is 5 plus 0.1 Vx. Again, solve this, and solving you get Vx is equal to, for this case, it is equal to 25. So what is our total Vx? So let us consider this as Vx2, the first one as Vx1. So total Vx is equal to Vx1 plus Vx2, and that is equal to, the first case we had got a 6.25 volt, and here it is 25. So we are ending up with 31.25 volt, right? So total voltage is going to be 25 plus 6.25 or 31.25 volt. So this is an example where we have used a dependent source. Okay, to summarize, when we are solving a circuit using superposition, you will consider one source at a time. So all the other independent sources are going to be turned off. So this will be also an independent source. All the other independent sources are turned off. Now, by turning off, you mean that if it's a voltage source, you have to replace it by short circuit. And if it's a current source, it's to be replaced by an open circuit. So each case you separately do, but at the same time, dependent sources have to be retained as such. They cannot be made zero. So once you do this, for each individual case, you solve the circuit using suitable technique, whichever technique you want, node analysis, mesh analysis, KVL, KCL, whatever it is, use suitable technique to solve, and then find the resultant current or voltage for a particular element which is asked. It's found out as a algebraic sum of the currents or voltages obtained with individual cases. So each case separately you find out, then add the different cases together. So from this you can understand that if there are multiple number of sources, if there are n sources, then using superposition you will have to do it n times. I'm speaking about n independent sources. Dependent sources, obviously we are going to be keeping it as such. So if there are n independent sources, when we are doing each case individually, you will have to do the problem n times. So if there are large number of sources, superposition becomes a little tedious, right? So this is about solving problems with superposition. Hope you understood. Thank you.